Hello and welcome to British Academy for another video. Today we will be talking about how to plot data with Matplotlib from the book Math for Programmers of Paul Orland. Pretty much this is what we're going to do, how to plot data with Matplotlib, making a scatter plot, making a line chart, and then making plot customizations. Yes, so this would be the topic of today's video. Let's start. For the video, we will be using Jupyter Notebook, and we'll start with making a scatter plot. And this will be cell type Markdown. What can we do in this cell type Markdown? We can do it like this, and then like that. And I was just pressing Shift and Enter pretty much. So making a scatter plot. So we put the X values, which would be 1, 2, 3, 4, 5, and the Y values, of course, that are going to be just the square root of this, not the square root, these values on the power of 2, so something like that, obviously. 4 is 16 and for 5 it's 25. So what should we do? We should say plt.scatter, and here we should say X values and then Y values. And as you see currently it said plt is not defined. So what does it mean? We should do some imports. So I'll just put the imports here. It's going to be import matplotlib.pyplot as plt, then shift enter once more, and tada! This is how the scatter looks like. Pretty much we have 1 with 1 here, 2 with 4, 3 with 9, 4 on the X values with 16, and then 5 on the X with 25 on the Y. Okay, looks like this, it's good. What can we do in order to make it a bit better? We can do plt.scatter.x values, or I can just copy this one. And then I can say, okay, I need a marker, and my marker is going to be X. And I need a color, and my color is going to be red. Red, of course, is a string. So you see, we get this one, axis, like that. I have researched a bit what can we use, actually, instead of axis, and it turns out we can do plenty of stuff. All the things are here. We can do a point, we can do 3 right, 3 left, we can do a hexagon, 1 hexagon 2. I'm going to use hexagon 1, just a H, just to see how it will look like. Yeah, if you zoom in a bit, you'll see this is a hexagon, or we can use a square S, and it's a nice square that we just got. Yeah, and now what if we want to go further and create a line instead of this? Let's think. So if we want to create it, the line is gonna be plt plot and then X values, Y values. Tada! We have the line. It just goes and it connects all the dots for us, so to say, which is definitely good. And we are already on point B42, making a line chart. So I am going to create here, write A, go with cell type Markdown, and copy this one into making a line chart. Okay, fair enough. So what can we do further if we want to make a line chart in order to ease our job, so to say? We can use a function that would be named plot segment, and the segment would be p1, p2, and here we would say, okay, x1, y1 is p1, and then x2, y2 is p2 or y2. I'm not sure whether you understand what y2 is. And then we say POT plot, pretty much this one. And instead of x values and y values, we'll be using like this: x1, x2, and then y1, and then y2. And then our marker would be, I would use this one because I don't remember what exactly it was, but it would be something. It is try left, whatever this is. Let's take a look. Okay, so the function is now ready. So our point 1 would be like this, 0, 3. And okay, point 2 would be something like 2, 1. And now we're going to plot the segment point 1, point 2. Just to explain once more what is happening with this function, point 1 would be given here, and it would be split to 0 and to x1 and to y1 in order to be point 1, and then x2 and y2 would be point 2. Anyway, let's take a look what will happen. Yeah, this is what happened, and these are our endings because of the tree. If we use a star, it would be a bit different. We would have a star for plotting the segment. Yeah, as beautiful as this, and of course we can always use a color. Color would be, we were using red, blue, let's use green. I'm just guessing that green should be existing. Yes, green exists. Not all color exists, but the ones that you can probably write exist. Now let's continue with something more interesting, pretty much with the sinus function. So x values here will be equal to np arrange 0, 10.001, and in order to have the np range present in our project, we should add it here. So it is import numpy snp, shift and enter to load it into the system, going back and pressing enter. So what exactly this thing here did? X values np arrange, let's see. So pretty much it just started from 0 to 10, creating all the values with a step of this. So if we have decided not to go with the step of this, but with the step of 1, then x values would be like this, from 0 to 10 with a step of 1. Fair enough. And then the y values would look like something better. The y values would be np.sin, and this sin is a sinus, and it would be the x values. So if we check the y values, these are how the y values look like. And what can we do here? We can say, okay, we want to plot it, plot x values and then y values. You see, this is really, I would call it not the most beautiful sinus function, because this is not exactly what a sinus function looks like. But this is a sinus function if we only are allowed to have 10 points. If we say, okay, let's the step be something like 0.1, It's already way better. If we want to go to something like this, you see here you start seeing the points because of the curliness. Yeah. So let's go with 0.01. Take a look and see the beautiful sinus function. Okay, so far so good, and we are ready for the last part of the video, more plot customizations. Shift and enter and nothing happens, so we have to go to cell type markdown. Still doesn't work, probably because of this. Yes, most plot customizations. So I just zoomed just to show you something here. As you see, it's obvious that on the X line we have only from 1 to 5, and on the Y line we have from 25 to 0. It looks like a square, but it's obviously not one. So it would be good if we can fix this a bit. So how do we fix it? That's a good question. Let's try something like this. Y lim 0 to 5, X lim 0 to 5. This would actually cut it from 0 to 5 only, and from 0 to 5 only there. Then plot.gcf like that, and then set size inches 5. Yeah, and then let's plot segment 0.1, 0.2. So instead this thing that we just pointed here, this would be looking different. Let's take a look. This is how the segment looks from 0.3 to 2.1, I would say. Is it correct? Let's see how the points were. Yes, 0.3 to 1 exactly. This would be another thing that would be interesting. Let's try this one once more. Yeah, didn't change because we had more values. True. I'm just thinking, should I try to do it this one or better not? Let's stick with the video. Okay, so further, what should we do? Copy this a bit more and then say okay, plot x values, y values, like that. And this is how things looks. We have already seen it. So we're going to write a title, x label, and y label, just to have everything nice. So plot title, this would be graph of scene x vs x. Yeah, makes sense. And here font size equals 16. This is how our graph looks like now. Okay, just copy this one and copy that one just to make things easier. So x label, and the x label is x value. We just put this one, x value, and for y label, y label, whatever you want to hear that one, the value of scene x. Tada! And you see that it automatically, I think, made this one as a title and a bit bigger than that one, and then that one, which is kind of good, I would say. But we still see that on the x values we have from 0 to 10 on the y value, which is the value of the scene, we have from 1 to 1, which actually makes sense. But if we want to have it like this one, we can start abusing a bit. So let's start with copying this, putting them here, see what is going to happen, and go. Yeah, from 0 to 5 we only get this part of the sinus. Yeah, okay, so it should be -5 to -5. Yeah, true. Actually, we didn't care about -5 on the x value, so the x could be 0, 10. And this is how our sinus function looks like. Pretty much, that's probably good. If we still want something, we can put a grid. Just for the fun of it, let's write plot.grid, and then a true should be enough. And we roughly start getting some idea about how the grid looks like, which I think should be enough for today. We can change the grid color if we need it. Yeah, let's change the grid color. Last thing last, plot.rc params, and then grid.color. Of course, this is not a value but a string, and the grid color would be something like 1, 2, 3, 4, 5, 6. And of course, this should be also string. Yeah, or we can put like 1, 2, 1, and then here 2. Or we can put any other color. And by any other color, for example, we can simply write red and it will work. So, just to summarize, this is what we did so far. We created a scatter plot with x values, y values. We scattered them. Then we showed that we can change the colors of the stuff. For example, we change the markers, for example, something like that. And of course, so the plot is always different because the values were different. But so let's go and fix everything as it was. So this is how it looks, yes. Then making a chart line, pretty much just going through the values and uniting them with a line, creating a function for plotting, connecting two points easily with the plot segment function, creating the sinus function, which is not probably nice enough because on the x-axis you see that it's going 0 to 10, and in the y-axis, it's going -1 to 1. And in order to fix this thing, we went to more plot customizations, which pretty much said, okay, we have a limit of y and x, and we are using with 5 inches, so it's okay. We plotted the segment here that was looking like this here, and at the end with this beauty here, okay, let's write a blue one, and we need to do it twice. We graphed the sinus function of x versus x. So thank you for watching, enjoy the rest of your day, and yeah, smile. Bye bye.